Hello, we are team number 12 and we are going to present you the final project delivery number 6 with bridge regression. First, we need to know how to work with nominal data. In some cases, nominal data may qualify as quantitative, as in qualitative data. This nominal data is used to label variables that does not have quantitative value. It can be analyzed by grouping methods, and with these methods we can find the frequency or percentage of the data, and that's how we can calculate a number. Nominal data cannot be manipulated using the normal mathematical operators like numerical data, for example. And the central tendency for nominal data can be the mode or the most repeated value, and a test that is used to work with nominal data is chi-square, and it determines the significant difference between the expected and observed frequency of certain values. And examples of nominal data can be people's name, genders, and nationalities. Bridge regression is a regression that performs a regularization named L2. This sets a penalty equivalent to the square of the magnitude of the regression coefficients and tries to minimize them. The formula for penalization is the LS object plus lambda times the sum of the squares of coefficients. If lambda is equal to 0, the output is similar to the simple linear regression. But if lambda values are very large, the coefficients will become 0. An increment in lambda leads to a decrement in collinearity results. And to find the optimal value of lambda with the minimum error, we can do it in R with the functions CV, point, GLM, and ET. This method could make a reduction in variance without increasing the bias, leading in a less error of the regression model. To work with the data sets, we make a program in R. For the CP, CSV, and for the tool CSV, we first read them. Then we make them as data frames. Then we eliminate the NAs by putting a 0 in that value, and in data tool in data tool we change if the tool was used. For example, here the tool 1 was used, or the tool 6. We only work with it like a single tool because there are 100 stages, and if there's a tool 1 in the cell, it will appear a 1 and the NA will transform into a 0. So we end up with a binary data. And we did the same for the CP, with the difference that we do not use any 1. We only end up with the continuous values and with a 0 where it appears at NA, to then eliminate that row because it will not give the information that we need. Then we compare the two data sets, and if there is no there is not a match in the name of the lot, that rows will be eliminated. First, comparing the CP data with the tool data, because in CP we have the values of the lot, of the CP lot, and then we compare the other way around, the tool with the CP, to know which lot. For example, here we have the 17 and the 18, but in the data set we only have, in the data set for tool, we only have 17, but no 18. So that lot will not appear. And this will find the values in the lot of lot in tool that are not present in CP, and then we eliminate them with this function to only have values that has a numerical value for CP and binary data for the stages. Then we make a plot simulating the data with stage 1, and we can see that we have 0 values and 1 values because it's binary. But making a box plot of the CP, we can see that they are outliers that are the 0 values. Then we transform it again to NA values and make out another time the plot. This stage 1 is only for illustrative explanation. We use other stages as the important variables. And now we can see that the box plot of the CP has few outliers and the range is less. And to obtain the values that have more impact in the CP value, we make an analysis of variance and then we sort them. The sort function gives us the lowest values, and we select the first 10, and the higher values that we select also the last 10 values. That was the variables that we use for that can give us a high CP or a low CP depending if they appear or not in the stage. In this case, if the tool is used or no in the stage.
Once that we have selected the 10 variables that affect the most negatively and the 10 variables that affect the most positively, we can start with our ridge regression. First, we divide it by the dependent and the independent variables with X and Y. The dependent variable would be Y, and our independent variables would be only the ones that affect the most. After that, we create our first ridge model. So we use a grid in order to create it, and we can see the plot of that ridge regression model. After that, we train our information or data. So we have to divide our data in a training set and a test set for both X and Y. After that, we feed this with this data with the training data. So we use the next ridge regression model, and with a seed and also a random seed, we use the CPGLMNet in order to obtain the best lambda. So the best lambda in this case would be 3.4. And then we calculate the MSE related to that lambda, and that would be 11.098. After that, we fit our regression model with the full data, and with the predict outcome, we obtain our coefficients for that best lambda that we obtained. So the results here would be the coefficients. We also obtain this graph. So this one is the graph for the CPGLMNet for the mean square error.